All right, good evening once again. So today's video, we are going to learn how to use Microsoft Excel to solve for linear programming. So what we did the last time, we are going to learn how to use Excel to solve it in within seconds or something like this. So let's move straight to the business. So let's read. We have a question here for us to solve. You get it? So we are saying that a phone dealer is preparing to make new orders for phone types Nokia, Samsung, and LG. The unit profit for Nokia, Samsung, and LG are 100 Ghanaian cedis, 300 Ghanaian cedis, and 50 Ghanaian cedis respectively. The phones are kept in a specialized protective container of 10.1 square meters to prevent cracks and other malfunctions from vibration. And Nokia, Samsung, and LG take space of 0.05, 0.1, and 0.05 square meters respectively. If a Nokia, Samsung, and LG cost 300 Ghanaian cedis, 1,200 Ghanaian cedis, and 120 Ghanaian cedis respectively, and the dealer has available 93,000 Ghanaian cedis to spend, what should be the optimal mix of phone types to purchase to achieve the maximum profit possible, right? So with this this question, with the LP we learned the other time, you know that this question is talking about what? The objective function is what? To maximize the profit. You get it? So our objective function is to maximize the profit. So we'll go through the 4 steps to formulate our expression. So first of all, we will define our decision variables. Then we move on to our objective function. We move on to the constraints. Then also we check the non-negativity constraint where all our decision variables are more than what? 0, greater than or equal to 0. You get it? So we are going to use the same process to work for this one. So let me share the white. So we are going to formulate it here manually. Then after we learn how to use the Excel to solve it. You get it? All right. So can you hear me?
Yeah.
Can you hear me?
Yeah, we can hear you.
All right. So with this one, what we learned last week, what will be the solution for this one? How are you going to start with this type of question? So if you are to do this manual, how are you going to start with this kind of work? Yes, anyone?
Okay, I would say the first one, we have to define the variables.
Okay, so first of all, we have to define the decision variables. So how many decision variables are we having in this question?
Okay, we have 3.
You said
3.
3, okay. So they are
the number of
number of
Nokia, number of Samsung, and number of LG.
Okay, so we let X1, S2, and S3 represent the number of what?
Of Nokia,
Nokia, Samsung, and what? LG phones. Okay. To order. All right. So this is the unknown quantity to order. You get it? All right. So now that we are done defining our decision variables, what will be the next one? So the first one, we just define decision variables. So what will be the second one?
The second one is the objective function.
Okay, objective function. So this one, what is the objective function?
It's maximum.
All right, so let's say maximize Z. You get it. Maximize Z. All right, so what will be the objective function? So we are saying that. So what will be the objective function? I would like you to answer it yourself. I'm waiting.
I'm coming.
You said?
I'm coming.
All right. Okay, so back for.
Okay, I think it's 10.1x1.
10.1x1
plus 0.5x2. Hey, sorry.
Come again. We are talking about the objective function. We are saying that the objective function is to maximize profit, right? So you will take the unit profit for the various phones. So you take the profit for LG, profit for Samsung, and profit for what? Nokia. Then you multiply it with what? The quantity. And the quantity or the number of phones to order is what we don't know here, right? Hello.
Yeah.
Hello.
Yeah.
Yes, okay. You take the unit profit of the various phones. You get it?
Yeah.
Unit profit. You multiply with what? The unknown quantity, that's the decision variables. So you multiply with the decision variables. Sum product of this will give us the objective function. Do you get it? All right. Okay, so this one, what will be the objective function? But for try again.
Okay, I'll go for.
You said
I'll go for the 0.05.
I think that one will be under constraint. Constraint as in the storage. The resource constraint storage. That
Okay,
one will fall under.
So is the cost rider.
So you take the unit profit of the various forms. Do you get it?
Okay.
So you take 100. You get it. Multiply with x1 plus you take the unit profit for Samsung is 300. Multiply by S2. You add unit profits of LG, that is 50. You multiply with what? The decision variable, that's the S3. So are you okay with this?
I didn't see that. I was looking downwards. I didn't see that.
Okay. So we move to what? How to be the test step?
First step is resource constraint.
Okay, so we are moving on to the constraint. All right. So what will be the first resource constraint? What will be the resource, the first resource constraint? Now, first of all, we are having two resource constraints here. So what will be the first one?
The first one is 0.05x1.
So that one is what? Storage space, right?
Yeah, storage space.
So the first resource constraint will be storage space. And that one will be 0. I'm listening. 0.0. 0.05 x1. Yes, you multiply with the decision variable.
Plus 0.1 s2.
1 s2 plus
0.05
s3
equals to.
Okay, so this one we are saying that Samsung and LG takes space of what? This. So it means when you add, you multiply this and add, you multiply the 0.05 with the addition variables and add with the various phones like the Samsung, LG, and what? Nokia. You do the same process. You add all of them. It shouldn't be more than what? 10.0, 10.1. You get it? So that one will be less than or what? Equal to.
10.1.
So the linear programming, bear in mind we have greater than or equal to, we have what? Less than or equal to. We have the equal to as well. So this one is talking about less than or equal to. So less than or equal to the space, the available one is what? 10.1. Now let me repeat myself again. Now I said you take we have LG takes storage space of 0.05, 0.1, and 0.05 square meters respectively. You get it? So for the various phone, Nokia is 0.05, Samsung is 0.1, and 0.05 is for what? LG. You get it? And you multiply these values here with what? The decision variables and add all of them. And when you add all of them, the available storage, you are seeing that the phones are kept in a specialized protective container of what? 10.9 square meters. So it is 10.1. So it should not be what? More than 10.1. That's why I use exactly 10.1 or what? Less than 10.1. You get it? Now, what will be the second constraint here? The second constraint, when you read through, you see that if a Nokia, Samsung, and LG cost 300 Ghanaian cedis, 1,002 Ghanaian cedis, and 120 Ghanaian cedis respectively, the dealer has available 93,000 Ghanaian cedis to spend, right? So this one, the next resource constraint will be what? Available amount available to spend, okay? Or let's name it amount to spend. Amount to spend. So this one, what to be the formulation? What to be the formulation? Quick.
300 x1.
300
x1.
300 x1 plus
1,200 s2.
1,200 s2 plus
120 s3.
120 s3. And I taught you this. No, this one is not equal to. I taught you this under linear programming when we are about to start. I said when you hear this word, available to spend, when you hear these words, available to spend. Now, for example, when you are having 100 cedis on you, you get it? You're having 100 Ghanaian cedis on you, and you have to spend that amount on you. You cannot spend more than what you're having unless you borrow. You get it? So what you spend, let's say within the 3 days, or I don't know how you're going to spend the money, should not be more than what the 100. It can be the 100 cedis, exactly 100 cedis, or what? Less than the 100 cedis. So when you hear these words, available to spend at most, but only, you get it? Not more than, then it means you are going to use the sign less than or what? Equal to. You're not going to use equal to. You're going to use less than or equal to. You are only going to use equal to whenever you see exactly. So this one was what? Has available to spend. So this one is what? 93,000. Less than or equal to what? 93,000. You get it? Then lastly, we want what? Our what? Non-negativity constraints. And this is where your decision variables, all of them are what? Greater than or equal to 0. So x1, x2, and x3 greater than or equal to what? 0, because you cannot order negative phones. We get it. It's either you don't order for some phones at all, like you don't order for Nokia, you don't order for Samsung, you don't order for what, LG, or you order more than 0, 1, 2, 3 phones. We get it. You cannot order for negative phones. I'm ordering for negative 4 phones. It is not possible. So that's how we go by it manually. Now with this same process, now that you've developed this, we don't know the value of x1, we don't know the value of s2, we don't know the value of what, s3. So you would have used matrix or something to solve for the values of x1, s2, and s3. But here is the case. You are going to use Excel, Microsoft Excel, to learn how to formulate this and solve for the values of what, x1, s2, and s3 within some seconds. Do you get it? Okay, so without wasting my time, let's move straight to what, the Excel. Okay, can you see the screen?
Yeah.
Can you see the Excel screen?
Yes, please.
All right, so we are going to learn how to formulate this in Microsoft Excel. Now there will be, I think, some few changes. The rest will be the same, but you see some. Let's move on. You see it yourself. Okay, so this is the Excel. This is the interface of the Excel. So we are going to use a certain app, built-in app in Excel called what? The solver. And some of you might not see the data analysis and solver here because you've not installed it or something like that. So what you do to install is that you go to come and hold on. Okay, so I'm going to teach you how to get this data analysis and solver. We are going to use the solver here to solve the linear programming. So first of all, I'm going to install this built-in app. So you look to the ribbon here, you check file. So this is the file. You click on it, you get it. It sends you to the backstage view. So you click on the file, you get it, on the file. Then you click, it sends you to what? The backstage view. Then you go to what? More. You choose options here. You get it. You wait for it to load. Then you move on to what? The add-ins. You get it. Click on the add-ins. Okay, so you see that I've already installed it. That's why you are seeing it here. So if you are new to this solver or analysis 2-pack or something like that, you will see the solver analysis 2-pack, analysis this 2-pack to be here in this inactive application add-ins. Then just click on it in the list below. If you find your solver here in inactive application add-ins, you just click on it. You click on go, then you restart your Excel. You get it. So because I've already installed this add-ins, that's why you are seeing it under the active application add-ins. But if you've not activated it, you see it as well under the inactive application add-ins. And you click on it, you click on go as well. You get it. Then you click on OK. So the moment you click on OK, it closes. Then you restart your Microsoft Excel. So after that, when you finish everything, you come to the ribbon here again. You click on data. When you click on data here, you see your data analysis and solver there. All right. So now let's move on to how to. Do you have any question before we move on?
No question.
All right. So let's move on to how to. Now on the first row here, you can start anywhere, but for similarity and uniqueness or something like that, let's use the first row. So the first row, we are going to type the decision variables. You get it? Decision variables. All right. Then you are going to, on the row that is here, horizontally, you are going to write your decision variables there. So the decision variables, we are having Nokia, right? We're having Nokia. We were having Nokia. The second one was what? LG, I think. Or Samsung. Samsung. This one is what? LG. Now on the second row, that is the cell A2. Cell A2 will be for the quantity. You get it? Or the unit to order. So just type unit to order. Now we don't know the unit to order. So senior man, what did you use to represent that unknown unit to order? Hello. Yes, S1, S2, and S3, but with Excel. Excel does not know alphabet. Do you get it? Excel don't work with alphabet. Excel work with numbers only. So because Excel doesn't know numbers or alphabets, we represent the decision variables by 0 instead of what? The x1, s2, and s3. We represent it by 0 because we are going to initialize our solution to be 0. You get it? So you take it as what? 0. We don't know. You get it? So Excel doesn't know alphabet. So when you represent it with what? X1, S2, and S3, you cannot use the solver here to get the values of what? X1, S2, and S3. Note, Excel doesn't work with alphabet. Excel works with numbers only. So we just initialize our solution by representing the X1, S2, and S3 to be zeros. You get it? So S1 will be 0, S2 will be 0, S3 will be 0. You get it? So 0, 0, 0. Now the third row, or cell in cell A3. In cell A3, we look at what? The unit profit. Unit profit. Okay, the unit profit. We know that the unit profit for Nokia was 100. Unit profit for Samsung was 300. The unit profit for LG is what? 50. You get it? Hello, did you get it?
Yeah.
All right. So now that you are done with the decision variables, now this one has to do with what? The total, the objective function. Objective function. Now with the objective function, we are talking about what? Maximize. So maximize Z. You get it? Now the objective function. What was the objective function like when you did it manually? What was the formulation? What was the expression? Can someone tell me?
Was 100x1 plus 300x2 plus 50x3.
Good. It was 100x1 plus 300x2 plus what? 50x3. Now in Excel here, we didn't represent the decision variables with the x's. We just initialized our solution, so we represented them with our zeros. Do you get it? So the x1 was multiplying 100, right? Hello.
Yeah.
The S2 was multiplying 300, right? The S3 was also multiplying what? See, the X1 was multiplying 100, S2 was multiplying what? 300, S3 was multiplying what? 50. But here is the case in Excel. We represented the X1 and S2 with 0. So in the workings, you are going to do it like this. X1 was multiplying 100. So now that we've represented it with 0, 100 plus 300, 100 plus 100 times 0 plus 300 times 0 plus 50 times 0. You get it?
Yeah.
Who can tell me the final answer for this?
0.
He said
0.
0. Good. So we are going to multiply the unit profit by what? The decision variables. And the decision variables, you represented it to at zeros. Okay, we represented it with zeros. Now, how are we going to do this calculation in Excel? What I just performed here? We have something we call sum product. You get it? We have something we call sum product. So we are going to use sum product to get what? The total profit or the objective function. That was to maximize our profit. You get it? So we are going to use a function called sum product. So to type a function in Excel, you are going to use equal sign. As I taught you how to use the matrix, the inverse, and those that. So equal to X, you type sum product. You get it? So it's here. You click on it. Now you drag through the unit profits. You get it? You select all the unit profits. Sorry, select all of them, the 3. Because you know unit profits, we're multiplying what? The unit order or the decision variables. That's the 0, 0, 0 here. So comma. So the unit profit, comma. You select everything on the what? Unit orders row. You get it? Then you press what? Enter to give you 0. So when you click on it, you see the formula here on the formula bar. So it was equal to sum product of all of this, comma, then you need to what? Order. Because we are using sum product, it will multiply and add as we did on the whiteboard. You get it? So now that we are done with the definition of decision variables, knowing our objective function. What was the third one?
Constraints.
Is it
Constraints.
okay? So we are moving on to the constraints. So the first constraint was what? The storage, right? So the storage we said we have under Nokia it was 0.05, and Samsung it was 0.1, under LG it was what? 0.05. Now we are going to have something here. We have something we call like resources or constraint used and the available resources. So let me name it utilization. What we have utilized, right? Utilization. And we also have what? Available resources. Now, how do we get the available resources? The available resources is what is stated in the question. So the available resources stated in the question was what? 10.1. You get it? 10.1. Now, how do you get the utilization? Utilization is what you have used, you've already used. You get it? So how do you get it? You just you use the same sample that you multiply with the question, with the manual something, what we did manually. Let me show it on the whiteboard again. You see, you just multiply the x1 with what? The 0.05, s2 by 0.1, s3 by what? 0.05, less than or equal to what? 10.1. So the 10.1 becomes our available resources. What is available for us to use? You get it? And this you multiply and add. That's why we call the sum product. Is what the totals of this becomes our utilization. What you've used. You get it? So when it comes to Excel, how do you get your utilization? On the whiteboard, it was 0.05 times x1. Here is the case in Excel, you don't have x1 because Excel doesn't deal with what? Alphabet. It deals with numbers. Excel knows numbers only. It doesn't know alphabet. You get it? So you just multiply the 0.05 here, which is the constraint, storage constraint for Nokia, by its unknown unit order that we initialize. That is 0. So 0.05 times 0 plus 0.01 plus 0 plus 0.05 times 0. The answer, what will be the answer? 0.05 times 0 plus 0.01 times 0 plus 0.01 times 0. If you multiply and add this, what will be the answer? 0. You get it? So how do you do it? Using the built-in function in Excel. You use the same sum product. Sum product, you type it, it's here, you select it. You get it? You select all the resources here. You get it? Because you are saying you multiply and add. You use comma. Then you also select the unit to order. That is the unknown. We initialize. You type on it, you get what? 0. Another resource is what? Amount to spend. So under it was 300,000 and 120. Can you see the Excel?
Yes.
300,200 and what? 120. Here, the available resource in the question was what? 93,000. That was the money available to use. And how do you know the money we've used so far? That one will be the same procedure. The utilization, you just multiply the various resource constraint amount to spend for Nokia, 300 Ghanaian cedis. Multiply with the unknown unit order that we initialize to 0. So 300 times 0 plus 1,002 times 0 plus 120 times 0. What will be the answer? So 0. So we use the same sum product to solve for this. Sum product, you get it. You select all the resources and the amount to spend, comma. Then you select the unit order as well. You press enter. Okay, now we have 0, 0 here, 0 here, and what? 0 here. So let me use, let's see, let me fill it certain color. Now we are going to get values for this what? Zeros. We are going to solve for the value of x1, that is 0 here, value of s2, that is 0 here, value of s3, that is 0 here. Then we find what? The objective function, that's the total profit, the maximum profit we need to, when we make that order, what will be the maximum profit? What will be the maximum profit we will get? You get it? The maximum profit we attain. We solve for that one too. And under the utilization too, we solve for that as well. Okay, any question before we move on to how to solve it? Any question? You said?
No.
So is everything okay?
Yeah.
Okay. So Excel understands only numbers. That's why we used the 000 as our decision variables instead of S1, S2, S3. Because when we use S1, S2, and S3, it will be difficult for us to solve for the values of what? The Nokia, the number of phones to order for Nokia, Samsung, and what? LG. That's why we initialize our solution to a 0. All right. So without wasting my time, let's move on to use the solver. You get it? So we are going to use the solver. So when you check the ribbon here, insert, draw, page layout, formulas, data. So I've already taught you how to add in the solver, the built-in app solver in Excel. So you click on data, you have Excel here. You have data, you click on the solver. You get it? You click on the solver. So we are going to use the solver. So data solver, you click on the solver here. You wait, a new there's a window or window will pop up. So you see here solver parameters. Now this is what you are going to use to solve for the values of x1, s2, s3, and solve for the total profit that the maximize Z, and what the utilization for storage, utilization for amount to spend. Then also it's going to give us reports on our linear programming. You get it? You are going to get reports on our linear programming. All right, so let's start straight. So we see here, look at the first one. So we have Excel in it because you've already selected a particular cell. So you see that this is the cell. See J11. So because this cell was active, that's why you are seeing the cell here. So the set objective, you clean everything there. Just click on the backspace, clear it. You see, make it empty. Then under the set objective, what is your objective function? What was their objective function, senior?
It was 100. It was 0.
Zero. In this Excel question, it was 0. So what was the cell for 0? That 0 we are talking about.
Was
So the cell is the intersection of rows and columns. So giving the name or the cell name. So just select the function that have the formula for objective function. Just select the cell. So what is the cell having the formula for objective function?
I thought
It is
B5.
B, then 5.
5.
You get it? B and 5. So it is what? B5. You click on it, B5. Have you seen it?
Yeah.
Have you seen it?
Yeah.
So B and 5. All right, let's move on. Okay, so the 2, you see 2 here, maximize, minimize, value of, you get it? So with the question, we said the objective function was what? Maximize profit. So we select maximize because Excel selects maximize as default, you get it? If it is a cost, you just select minimize here. Now let's move on to the by changing variables. What are you going to write or what are you going to select under the by changing variables cells? Now under by changing variable cells is the quantity of the variables that we don't know. Do you get it? So in this question, we are talking about what? The number to order for all the phones. You get it? So number to order for all the phones. So all the numbers, you get it? So if we are saying all the numbers, then it means we are going to select all the 3 cells for the what? For the phones to order, like the unit order. So you click on the by changing variables, you select these 3 cells. You get it? Unit to order. Unit to order. You select their cells. So you select the cell for Nokia. So you select the zeros. Yeah, let me put it that way. The zeros. The zeros and beside the unit order. So you select all of them, the 3. Then you move on to what? The subject to constraints. Subject to constraints. When you reach here, the empty space here, the white space here, you click on add. You get it. Now the cell reference, you have cell reference, you have constraints, you have less than or equal to. Now with the cell reference, you are going to select. So this one you're going to select the constraint, right? You have the storage amount to spend. So the cell reference, you are going to select the utilization for that constraint. So the cell reference, let's start with the first one. Cell reference, we have storage. The utilization is what? Cell E7. You get it? E7. That's the 0 here. Select it like this. Then you move on to the constraint. What is the constraint? The constraint is talking about the available resources for that constraint. So the storage, the 10.2, and that one's F7. So you select F7 here. Then you choose your sign, less than or equal to, greater than or what? Equal to. So with this question, you formulated it as what? Based on the program or the question given, it was less than or equal to. So Excel will select less than or equal to for you by default. You click on what? Add. The moment you click on add, it means the one you did has been saved. So you are now moving on to select a new constraint. So let's move on to the new constraint. That is the amount to spend. So in a cell reference, you select the utilization. So here, the utilization for account to spend is what? E8. Select it. It is less than or equal to. The constraint is what? The available, the 93,000. That one is what? F8. You select it. It is less than or equal to. Then you click on add. We are going to add that non-negativity constraint. That one, it is not on like the screen, but remember under linear programming, I taught you how to, we have 4 steps. First of all, define decision variables, objective function, constraint, and what? Non-negativity constraint. Non-negativity constraint means your decision variables should not be what? A negative number. So it's either equal to 0, that you don't produce at all, you don't buy at all, you don't order at all, or you order, you produce, you buy. So it's either equal to 0, the decision variables are equal to 0 or greater than 0. So under the cell reference, we are going to select all the 3 zeros here, the unity order. Select it, all of them. Then this one, it is greater than or equal to, because every non-negativity constraint, it's greater than or equal to 0. So greater than or equal to 0 is the third one. Click on it. Under the constraints, available one, so it is 0, greater than or equal to 0. Then because we are done with all of them, click on OK. So when you come here, you see that the subject constraints are here. This one is already checked. Select a solving method. It is what? JRG nonlinear. Just change it to what? Simplest LP. Simplest linear programming. You get it? Simplest linear programming. Simplest linear programming. Then you click on what? Solve. So we click on solve. You see something here, keep solver solution. Now click on this answer. Click on what? Sensitivity. Sorry. Then you can click on return to solver parameters if you want to do what if analysis, like you want to change some of the variables you've already done. So you click on what? Okay. So see, look through look at this worksheet. We have answer report, sensitivity. So this sensitivity and answer report is talking about what we just formulated. Now the value of x1, or the value of the number of units to order for what? The number of phones to order for Nokia was what? 94 phones. The number of phones to order for Samsung is what? 54. And we shouldn't order LG. And our total profit is what? 25,600 Ghanaian cedis. Then the utilization for storage is 10.1. Amount to spend is what? 93,000. You see the reason why I gave these cells like I filled it with different colors, because at first it was 0. It was 0, and I needed you to concentrate on that part, because after using the solver, the zeros are going to change. But this side was 0, this side was 0, this side is 0, this side is 0, this side was 0, this side was 0. But at the end of by using the solver, you change the variables. You get it? Hello, is someone talking?
Yeah. No.
Yes.
Continue. No one is talking.
Any answer for like any question for me?
Okay.
Okay. So you see that this side, this is the maximum profit that we can attain. 25,600 Ghanaian cedis. When we order for 94 Nokia phones, when we order for 54 Samsung phones, and for LG, we will not order some at all. It is 0. The utilization means what we've used. You get it? And what was available. So with this one, we've used all the available resources. And amount spent to, we've used all of them. Now let's move to the sensitivity to see what is there. That one, I will explain it deeply another time, but let's see how it looks like. So you see that the same work, we have unit to order for Nokia, that is what? 94. You need to order for Samsung, 54. You need to order for LG, 0. We have reduced cost, 0, 0, negative 20. Objective coefficient was the unit profit, 100, 350. Now the available allowable increase and allowable decrease. So let me explain this more. The allowable increase is the highest increment, like your highest amount, the highest increment that you can make, so that everyone else can afford to buy or to order for the funds. You get it. And the decrease, allowable decrease, is what the lowest, the decrease, the lowest one. I don't know how to put it. So that is the lowest decrease one can decrease his or her profit, so that I'll get time and explain that part. The allowable decrease and allowable increase. You get it. So you see this one to sell. This one too is talking about the utilization. So the constraint. So this one is what storage utilization. So what did we use in our storage? The final value is what? 1. And the constraint, that's the right hand side. This one is what? 10.1. This one to amount to spend utilization to 93,000. The constraint was 93,000, the available one. So this one, the available increase, allowable increase, and allowable decrease too are here. Like the highest you can go, the lowest you can go. That's what the highest allowable and the increase and decrease is talking about. So you see, I taught you something about binding and non-binding constraints. Do you get it?
Yeah.
When you look through this, you see that the storage as a resource constraint was binding, because our utilization, what we used, was equal to what was available. When it comes to amount to spend resource constraint as well, what we used, what we utilized, was equal to what the amount available. That's the 93,000, and it is 93,000. So it is binding. So look at the answer report here. You see that the solution time, it is 0.109 seconds. You get it? It is not up to even 2 seconds. 0.1. Then it solves everything for you. But manually, you have to write it yourself, go through metrics or something like that to solve for the values of x1 and x2 and x3 before you can work if this one is binding, this one is non-binding. But with Excel, 0.109 seconds, you have everything here. Do you get it? So objective cell, the max Nokia means the total of the objective function. At first it was 0 because that was our initialized solution. Then the final value is 25,600. That means that is the profit we can attain. The highest profit, the maximum one. You cannot go beyond it. If you go beyond 25,600, you start to make loss. Then the variable cells, you need to order for Nokia, you need to order for Samsung, you need to order for what? LG. First it was 0000. Now it is 94, 54, and what? 0. Now let's move on to the constraints. You see, I was talking about binding and non-binding something. So when you take storage as a resource, it was binding because what we used was equal to what was available. The slack will be 0. I taught you slack and surpluses. So slack, you see slacks in what? Profit question. You see surpluses in cost question. Amount to spend as a resource constraint. The utilization was equal to what? The available resource. That was 93,000. So that one too, the status is what? Binding. You look at Nokia, you are saying it's non-binding. Why? They are teaching everything here. Because 94 is equal to 0, it's non-binding. The slack is 54. The unit order, it is what? Non-binding. Because first it was 0, now it is 54. So it's not equal. But the unit order, we initialized, answer gave us what? As 0. So this one too is binding. So basically, this is how Excel works. You get it in the linear programming function. All right. So this is how we use Microsoft Excel to solve for linear programming question without going through all the long process, doing it manually. You have to define a decision resource, you do everything. You solve for the values of x1, x2, x3. Then you come and give report. Whether this one is binding, this one is not binding. You solve for what? The allowable increase, allowable decrease. If there are slacks, there are surpluses, a whole lot of stuff, and you waste your time. But with Excel, you get everything. You get it. So, any question before we move on to solve the second question under LP? Any question?
No question.
He said,
No question.
okay. All right, Ajimai, do you have any question? Tina, do you have any question, Ajimai?
No.
Okay, so I guess you got everything. So let's move on to solve the second question under solver. You get it? All right. Let's move on to the second question. All right. So someone should read it one for me.
A dietitian can purchase 3 different types of food supplements: type A, type B, and type C. Each food supplement type comes in the same size.
Okay, senior, read.
Each food supplement type comes in the same size bag. For one bag of type A, it contains 5 mg.
I'm waiting, Charlie.
I can't see all of them.
Okay. Hope it's good now.
No, please.
What about this?
You have to push it to the right hand side. Yeah, I see it now. Okay. For one bag of type A, it contains 5 mg of nutrient 1, 10 mg of nutrient 2, and 5 mg of nutrient 3. For a bag of type B, it contains 5 mg each of nutrient 1 and nutrient 2 and 10 mg of nutrient 3. Type C contains 10 mg of nutrient 1, 60 mg of nutrient 2, and 60 mg of nutrient 3. For a particular patient, the dietitian determines that she needs to combine the bags of food supplement to get at least 1,200 mg of nutrient 1, 2,000 mg of nutrient 2, and 2,200 mg of nutrient 3. If type A, type B, and type C cost 3 cedis, 4 cedis, and 10 cedis, respectively, how many bags of food supplements of type A, B, and C should she purchase? Assume X1 and X1, X2, and S3 as the number of bags of type A, B, and C respectively. Round the answer to the upper integer.
Okay.
Yes, I'm done.
Thank you, senior. So with this type of question, how many decision variables are we having?
Oh, there are 3.
There are 3. Okay. And how many constraints do we have?
Constraints to
Resource constraints. How many resource constraints do we have?
there are also 3.
Also 3. Okay. So what I taught you, I said, can you see the Excel as well?
Yeah. Yeah.
Okay, so the first rule I said is for what? Decision variable,
Decision
right?
variables.
All right. Just extend it small. So the decisions are what? type A,
type B,
type B,
type C.
type what? C. Then the next one will be what? The quantity. So in this question, we are having what? They said this one is not unit order. Let me. So how are you going to name this one? Is it the unit will be what? Represent the number of bags or something. All right, so let's name it as number of bags. All right, so under type A, we said the number of bags to purchase, we don't know, right? So it's supposed to be X1, S2, and S3, but I said in Excel, it doesn't deal with what? Alphabet. It deals with only numbers, numerals. So just initialize our solution. So 0, represent them with 0, 0, and 0 here. You get it? Then we move on to what?
Sorry, the objective function.
No, not objective function. Come again. Come again. But the last one we did, we saw something before objective function.
The constraints.
You said,
Constraints.
now look at it. You see, you have unit profit, right?
Okay.
So this one too, we are going to have what's it cost? Yes, so this one is cost, unit cost. Okay. So this one is talking about unit cost. So the unit cost, look at this part. He said if type A, type B, and type C cost 3 cedis, 4 cedis, and what? 10 cedis. So for type A, it's what? 3 cedis. For type B, is what? 4 cedis. Type C is what? 10 cedis. And you move on to what? Our objective function. You get it? The objective function, this question, what do you think the objective function will be?
Is minimum.
Minimum, right? So minimum Z or something, so minimum Z. So as we did to the first one, how do we get our data function? It is the unit cost here times the number of bags unknown. So it is 3 times 0 plus 4 times 0 plus 10 times 0, which will give us 0. Good. So you just have to use the sum product to get the 0 here. So equal to sum product, you type sum product. Right, it is here, you click on it. Right, you select all the 3 cells for unit cost, comma. Then you select all the 3 cells for number of what? Bags. Then you press on what? Enter to give you the 0 here. Now the next one will be what? Constraint, right? So under constraint, this one we say we have 3 constraints, and they are, what are the constraints? What are the resource constraints?
What's Akata rule?
He said
It's 10 mg.
I mean
Sorry. It's 10.
I mean the constraint, resource constraint, as we were having
okay.
storage and amount to spend. Yes. So this one is what? Nutrients. So we have nutrient 1. We have nutrient 2. We have what? Nutrient 3. So let's move straight to formulate everything. Now with this one too, okay, let's finish with it. And nutrient 1. when you read the question, you see that for one bag of type A, it contains what? 5 mg, 5 milligrams of what? Nutrient 1. For type A, it contains 5 mg of what? Nutrient 1. Let's move on to the type B for nutrient 1. For a bag of type B, is it?
Okay.
Hello, come again.
10 mg.
It says, so I can hear you. For a bag of type B, it contains 5 mg of each of nutrient 1. So for type B2, the nutrient 1, it is what? 5 mg. Now let's see type C, nutrient 1. See, type C contains 10 mg of nutrient 1. So type C, nutrient 1 is what? 10 mg. Do you understand?
Yeah.
So with this one too, we are going to have utilization what we used. You get it? And our available resources. Now when you read through the question, you see available resources for what? Nutrient 1. So read this part. You see that the dietitian determines that she needs to combine the bags of food for a particular supplement to get at least 1,200 mg of nutrient 1. So that at least 1,200 mg becomes our available resources. You get it? So if you were writing it manually, what do you think the operation sign will be? Is it going to be less than or equal to or greater than or equal to? We have at least here.
It's less than or equals to.
At least. I always tells you that at least and at most, it confuses a lot. So at least is greater than or equal to, at most is what? Less than or equal to. Okay. All right. So the utilization, who can tell me how to get the utilization here? I taught you that in the previous question. How can you get the utilization here?
So the utilization, we are going to multiply the nutrient 1 by the number of bags.
Okay, so we are going to do sum product, right? So the function is sum product. So you click on the cell equal to it have sum product. This here you select. So you select all the resources for nutrient 1, comma, then the resources for what? The bags, number of bags. You press enter to give you 0. You get it? He said.
Oh, not you.
Okay, so let's move on to the nutrient 2. So nutrient 2, we are going to check type A, type B, type C, and the available resources for nutrient 2. So let's move on to the type A again. So for one bag of type A, it contains 5 mg of nutrient 1. It has been taken care of. And 10 mg of nutrient 2 under type A. The nutrient 2 is what? 10 mg. Let's move on to the type B. For a bag of type B, it contains 5 mg each of nutrient 1 and nutrient 2. So here to the nutrient 2 is what? 5. Now let's check the type C. Type C here contains 10 mg of what? Nutrient 1 and 60 mg of nutrient 2. So the type C nutrient 2 is what? 60. Then when we read to the question, the dietitian is saying that at least 2,000 mg of what? Nutrient 2. So that becomes the available what? Available resources. That is 2,000. Then the same way we calculate for the utilization, it is equal to sum product. of this nutrient 2, comma, the number of bags, you get it, to purchase. That one is 000. You press on enter to give you the 0. So this one, the constraints are 3. So let's move on to type nutrient 3. So you move on to type B, type A to C again. So for type A, it contains 5 mg of what? Nutrient 3. So type A, the nutrient 3 is what? 5. Type B, for a type B, for a bag of type B, it contains 5 mg of nutrient 1 and nutrient 2 and 10 mg of what? Nutrient 3. So type B nutrient 3 is 10. Let's move on to the type C. So type C. It contains 30 mg of what? Nutrient 3. So this part becomes 30. Then what is the available resources? The available resources says that 2,200 mg of what? Nutrient 3. So the available one becomes what? 2,200. Then the utilization to the same one is equal to some product. Select it. The resources for nutrient 3, comma, the number of bags to purchase 000 times to give you what? This. The question is saying we should run our answer to integer. Okay, so this question, bear in mind, all the cost question moves with what? Greater than or equal to. Then all the profit questions, maximum profit. You get it? That one too moves with what? Less than or equal to. All right. So now that you've able to enter the data, you're going to use the solver to solve for it. So let me make sure this the 000 aspect with a different color, right? Let's go for this color. Okay. So now that we are done, I said you go to the ribbon, you move on to what? Move on to the data. You get it? When you move on to the data, you see solver there. If you open the solver parameters. Now with the set objectives, I told you that always it will select the active cell. So it's selected it, and we don't want this cell H6. So we just clean it. See that the set objective is what? Empty now. Now the set objective is always the cell for what? The objective function. So what is what the cell for objective function? It was what? B5. So we just click on it, B5. It will select it here. To maximize, minimize. So this question, is it talking about maximize or minimize? It is cost. So will we minimize our cost or maximize our cost? Minimize. So minimize. So you click on the minimum. You get it. And I told you that by changing variables, you select what your decision variables or the initialization. So you select all your 3 zeros cells. You get it under the by changing variables. Now you move on to the subject to constraints. You click on add. So I told you the cell reference, you are going to select the utilization. Constraint, you are going to select the available ones. So the cell reference for nutrient 1, cell reference utilization for nutrient 1 is what? This one, G7. You get it. Then constraint here, you select what? The available one. It was F7. Then bear in mind, this one is not profit question, so it's not less than or equal to. It is what? Greater than or equal to. So you change it to greater than or equal to. You click on add. Nutrient 2. The cell reference is utilization. The constraint is available 2000. You click on this. Click on the cells. All right. Just click on the cell. Don't type anything. Just click on the cells. So this one too is not less than or equal to. It's greater than or equal to. Click on add. Nutrient 3. The cell reference, you go for utilization. This one. Change it to greater than or equal to because it's a cost question. We want to minimize our cost. But then the constraints, we change it to what? We select the available for nutrient 3. Then you add. Then the last one, you will not write it here, but you have to do it. That one is what? The non-negativity constraint. And you know that non-negativity constraint, when you are writing it, all your decision variables are greater than or equal to what? 0. You get it? So under cell reference, you select the number of bags, the zeros, you select all the 3. It is greater than or equal to the constraint, the available one is 0 for non-negativity. Then click on OK because this is the last one. Click on OK. These are the subject to constraint. Make unconstrained variables non-negative. You get it? So it is checked already. Then select a solving method. As I said, change it from GRG nonlinear to what? Simplest LP. You get it? Simplest LP. Then you click on solve. Now, the moment you click on solve, you see that the zeros here in the colored cells will change. So you see solve. So you see that it has changed. You get it? So you click on the answer sensitivity, you click on what? Okay. So you see that the number of bags to buy for type A is 60, the number of bags to purchase for type B is what? 160. The number of bags to purchase for type C is 10. Then the cost, the total cost we incur is what? 920 Ghanaian cedis. Then this one to the utilization, all of them were equal to what? Available. So it means it was binding. You get it? So let's move on to the how do you say it? So the sensitivity report for this type of question. So you see that type A, the final value is 6010. Okay, so this one too, you see we have final value, so number of bags of A, number of bags type A. You see that the final value was 60, 160, 0. By initially it was 0, 0, 0. Objective coefficient, that was their cost. And the allowable increase, the highest you can go, allowable decrease, the lowest you can go. You get it? Then let's move on to the constraint, that's the utilization. The final value, you get it? The final value and the constraint. So this one, the final value and constraint, are each side, the right hand side, left hand side were equal. So the shadow price too, I will explain that one later. So you see that 1,2, 1,2, 2,2, 2,2, 2,2. So they were all at binding. So allowable increase, the highest you can go, allowable decrease, the lowest you can go. You get it? Then let's move on to the answer report. The answer report, you see, the cost is what, 920. So this one to the seconds was what? 0.063. So when you are using Excel, you are even safe. It's not even up to 1 second. You get it. You get your answer. So number of bags type A, initially it was 000 for type A, B, and C respectively. Now it is 60, 160, and 10 for type A, type B, and type C respectively, right? Let's move on to the constraint. Let's check if they are binding or non-binding. Nutrient 1 to 3 were what? All binding. Because the utilization was equal to what? The available. So it was binding. There were no slash for it. And this one is because we initialized our statement, it will not be binding. You get it? So this is how we use MS Excel to solve a linear programming question. So any question from me? Do you have any question? Do you have any question?
Yes.
He said,
Bro, can I get the video or the recording?
he said,
Can
come
I
again.
get the recording?
Oh, I'll share the link.
Okay.
I'll share it, don't worry, you get it. So any question?
No question.
Okay, so let's solve one more question, then we end for the day. Then next time we meet, we are done with linear programming. We just start with what? Probability, where we learn binomial distribution and Poisson distribution. You get it? All right. So we will end here, but we are going to try one more question. Okay. So the question I want us to solve is to use, I want us to test something here. Okay. You see that question we solved with linear equalities, where we use the graph to solve for the value of x1 and x2. Do you remember that question? You got it to be 20 and 60 for x1 and x2, where the two lines meet, the intersection point. So with all of these ones, you can use Excel to check if you answer. This one we didn't solve for the answers. Or you can use Excel to solve all these questions. You get it? The LPs that we solved. The wooden carving, the Geopitos wooden carving, and those types. You can use the procedure here to solve for it. I want us to solve a particular question here. Talking about the linear equalities, not inequalities. Yes, this one we got it to be what? S1 to be, it was 20 and 60. I'm coming. Don't know if this type of particular question. So I've forgotten that question. I'm coming in. Hello. It was Geopitos, that first question we solved under LP. The first question we solved, where they manufacture soldiers toy and train toy or something like that. Okay. This particular question. All right. So, Senior, read it for me. We've already done it, so we know the decision variables, we know the constraints, we know the objective function. I just want to use the Excel to prove that we can use Excel to solve as well. All right. Because this one we use graph, and the graph give us the answer as what? It give us the answer as 20 and 60, right? Yes, yeah. 20 and 60. The highest one was 20 and 60. And the profit highest one was what? 180. 180. Right. So we are going to use Excel to get 180 as our total profit, values of X1 for 20, values of S2 as what? 60. All right. So Senior, read a question for us.
Pepito Wood Carving International manufactures two types of wooden toys, soldiers and trains. Soldier sells for 3 cities and the train sells for 2 cities. The manufacture of wooden soldiers and trains requires 2 types of skills: labor, carpentry, and fiction. The soldier requires 2 hours of fiction labor and 1 hour of carpentry labor. The train requires 1 hour of fiction and 1 hour of carpentry labor each week. Should I continue?
Yeah. Yes, are you done?
No.
Finish it.
People can obtain all needed raw material, but only 100 fiction hours and 80 carpentry hours. If at most 40 soldiers are bought each week, and Capito want to maximize weekly profit, formulate a mathematical model of Capito's situation that can be used to maximize Capito weekly profit.
Okay, thank you, Senior. So look at these words, but only. So what will be the sign to use So I told you when you hear but only is what? Less than or equal to. So the available resources for finishing hours were 100. Carpentry hours were what? 180. You get it? And the two types of wooden toys that will be the decision variables are soldiers and what? Train toys. And the maximum, the objective function, that one is to maximize profit. The soldier, that's the unit price. So the unit price for soldier sells for what? 3 cities. So one soldier toy sells for 3 cities. So 3 times x1 plus 2x2, that is the train to their unit selling price. So this one will give you the total, the objective function. So 3x1 plus 2x2. All right. Now we come to the resource constraint. The resource constraint, we will have carpentry and what? Finishing. You get it? And the soldier requires 2 hours of finishing labor and 1 hour of what? Carpentry labor. That is soldier. A train requires 1 hour of finishing and 1 hour of what? Carpentry labor. So this one tweet is talking about maximize. Now, the moment you hear maximize, I mean the profit. Bear in mind that it is what? Less than or equal. Right. So let's move to Excel. Then you do everything there. All right. So with Excel, I said the first row. The first row is for what? Decision variables. It's bad for here. Bad for. Bad for, are you okay? Can you continue?
Yeah, let's continue.
Okay, so we have the first one is decision variable. So the decision variable, we know it to be what? Soldier toy and what? Train toy. So soldier and what? Train. The second rule I said we used to. So this one is the selling price or unit selling price. Yes, unit selling price. Selling price. So you said a soldier sells for 3 cities, train sells for what? 2 cities. Then, oh sorry. The first one will be the number of train toys. The second rule is the number of train toys to produce. So this one will be the third one, right?
Yeah.
The third. Okay, so the second rule is what? The toys, the number of toys to produce per week. You get it? Okay, so this one we represented it with x1 and s2 when we were doing the graphical method, when we use a graph to solve. But I told you Excel doesn't work with what? Alphabet. It only works with what? Numerals, numbers. So use 0, we initialize our solution. So it is 0 here, 0 here as well. We move on to what? Our objective function. You said, so the objective function is to what? Maximize our profit. So maximize Z. So it is what? Sum product of this one and what? This one. So just click here, equal to sum product. You get it. Then you select the 2 here, comma. You select what? The number of toys to produce, the 2 cells. You press enter, you get 0. Let's move to the constraints. We've already done this, that's why I'm moving fast. Right? So the constraints, we have finishing hours. We have what? Carpentry hours. So we said a soldier requires 2 hours of finishing and 1 hour of what? Carpentry. So 2, 1 here. And we are saying a train requires 1 hour for finishing and 1 hour for carpentry. So 1, 1. Then the utilization. We have utilization here. We have available. Now we are saying available resources for us to use. The number of hours for finishing. You say we have 100 hours, we have 80 hours for carpentry. How do you get the utilization? Is the sum product of this one and the number of toys to produce, that's a 0 or no. So it is equal to sum product. Select this one and this one. Please, I beg someone is distracting us, please. Then this one to be equal to sum product of these resources here, comma, the values here, enter. So I want us to take note of this part. Let's select the 0 part, fill it with different color, so that at the end you see that you've done something here. Okay, so let's click on data here on the ribbon solver. So the objective, set objective with this one. Select your maximum the objective function, the cell that is having the objective function. This one is why B5. Select it. This one is talking about profit, so it is maximum. By changing variable cells, you select then unknown quantity, the 0 zeros. So you select the 2. This one it is 2. Now, subject to the constraint, you click on add. Cell reference is for utilization for that particular constraint. So finishing hours utilization is what? D7. It's less than or equal to. Bear in mind it's profit, but they also said but only. So less than or equal to. Constraint, you select the available resource for that 100. That's E7. Click on add. The carpentry hours cell reference, the utilization is D8. Less than or equal to constraint is what? E8. Click on add. Then you go to a non-negativity constraint. That's the last part. So that one is also what? Your zeros. Then it will be what? Greater than or equal to what? The constraint is what? 0. And click on what? Okay. Change this one to what? Simplest LP. So by
didn't add the demand.
He said
It didn't add the demand.
Demand.
The X1 less than or greater than 40.
40.
But with
Okay.
this one, it is not compulsory to add it.
Yes, if you don't add it, you will still get it. Because this one, there was no S1 and S2. That's why I ignored it.
Okay.
Get it. So you click on the answer here. Sensitivity. You click on OK. So by clicking on it, you know that the finishing hours here, it is what? Binding. The carpentry hours to the resources, what? The constraint is binding because the utilization were utilizations were all equal to what? Available. Then the number of toys to produce for soldier is 60. That's per week. And the number of trained toys to produce per week for Jupiter's wooden carving incorporated to produce per week is what? 60. Weekly. For them to attain a weekly profit of what? 180 Ghanaian cedis. So let's look at the graphical method if you got the same thing. So when we use the graphical methods, we got X1. When we use the graph, we got X1 to be what? Got X1 to be, that's the point. So X, the highest value, it is 180 Ghanaian cedis. So X1 is 20, X2 is what? 60. You get it. But the same thing is in the Excel or on the Excel sheet. You get it. So we have 20, 60, highest value is 180. So this is how we use Excel to solve for LP. So any question before we close for the day?
No question.
You said
No question.
No question.
what about the other people?
Yo,
Yep. Yep.
Sapon. Oh.